Right, so hello and welcome to the ongoing AS and A-level Python series, and in this episode we are going to be looking at polymorphism. So polymorphism, it's actually not a concept that is unique to just Python, but it's also available in other languages like Java and C#, right? So essentially, let's start by looking at the word polymorphism. So poly means many, and morphism, or rather morph, means form, is it? So by polymorphism, we are simply saying that we are taking it, we are looking at many forms or many shapes, as it were. So essentially, specifically when we are talking about object-oriented programming languages, or rather when we are looking at OOP programming, we are looking at one interface that is taking many forms. So according to the definition that I have going on here, you see that we say it is the ability of different objects to respond to the same method or function call in different ways. So why is it important to know about polymorphism? Well, because it allows us to write flexible code, it allows us to reuse code, and it also allows code to be extensible. I mean to say that we can extend the functionality that we already have existing to suit a different use case, as it were. And it's also basically going to give us a clean way of writing good object-oriented programs, as it were. So in this particular episode, polymorphism actually goes way deeper than just the four methods that I have, or rather the four areas that we are going to be looking at right here. But I think these ones are enough, or they are sufficient for the purposes of this particular course. So we will start by looking at polymorphism with built-in functions. So maybe let's start with something that we already know. We already know that we can, to print something in Python, make use of the print keyword, as it were. Maybe let me just zoom in a little bit so that you guys can see the screen a bit better. So what we're going to do, we know that we can print, like for instance, print is actually a very good example of how one function can take different objects and just display them onto the screen. So for instance, if I say print 25, then I can say print hello right here. Then I can also even print maybe say even a float, right? I would say print then maybe 8.25, right? If I go ahead and run this code, let me just go ahead and invoke the Python interpreter. So Python polymorphism py. Already you can see that we have different objects. So the objects here that we have an integer, we have a string, and we also have a float, as it were. And essentially they are just responding to the same function, which is the print function. So if you come back to the definition of polymorphism right here, you see that earlier on you said it is the ability of different objects to respond to the same method or function call in different ways. So in this case, really, you might argue that there's nothing really different because we are just displaying the object, as it were. So I would actually take this example a bit further by using the length function on each of these objects, as it were. So maybe let's actually go ahead and say print. Then we can also call the length function inside of print. So this is actually called method chaining. When you call a method within a method, essentially that's called method chaining. So what we can do here is we can say print, maybe let's use a string for this one, because the length function works well with strings, lists, and tuples. So let me print the length of hello. Then I can also go ahead and print the length of, maybe let's pick a tuple this time around. Let's have inside of the length we can have another extra set of brackets, because that's how you define tuples in Python. 20, 30, just like that. Then we can also go ahead and print say maybe a list. So we can actually just define the list right there in the inside of the length function. So let's have a list like 1, 2, 3, 4, maybe just 5 for good measure there. Right, so you see that here we have different objects, is it? So here we have the hello object, which is a string, and let me just put comments here. The comment here. So this is a string. That's a string object. Then here we have a tuple object, and here we have a list object, is it? So just as before, these objects were responding to the print function, right? We can also do the same thing by these with these examples of this string, this tuple, and this list. So if we go ahead and run this code, you actually see that we get the length of each respective object, is it? So this is actually polymorphism in action, and for this particular example, we are looking at how this length function is going to count the characters. Then for the tuple, it's going to count the elements, is it? Then it's also doing the same thing for the list. It's going to count the number of items that we have going on in the list. So that's the very first example that I wanted to show you about polymorphism with built-in functions. Then we are going to move on to look at polymorphism with user-defined functions. It's not just limited to built-in functions. So let's actually go ahead and start. Let me just scroll up a bit. So we're actually going to go ahead and maybe define our own function called print length, right? So inside of this function, we're simply going to we're actually just going to leverage the value rather than the function print that is already defined inside of the Python library. Then our print length function is going to take a parameter which we are going to call item. So item can be anything. It can be a string, it can be a number, it can be a tuple, it can be a list, is it? So here we've defined our own function called print length. Then what we can do here is we can then go ahead and call print length right here. So in the first example, you can pass maybe a string. Maybe let's call this string Python programming right here. Then in the second instance, we are going to call print length with a list, just as we did before earlier on. So let me just, because I'm too lazy to type, so I'm just going to go ahead and copy this right here and paste it inside of here. Is it? So let's actually go ahead and clear the screen here so that you can see fresh output. Okay, so it's not really clear because we have that output going on here. So maybe just before we put our function here, let's just print this line, sort of like a border, as it were. Let me just put double quotes there. So let's just put a line like that. Then go back to the console, clear out the console, then run that script one more time. Like so, this is the output from the previous section. So this is the output that we are concerned with right here. So as before, again, you see that we are simply counting the number of characters that are inside of this particular string right here on line 21, is it? Then in the second instance, we actually have that list going on, and it has 5 elements. So just as before, really, we're just counting the number of characters, and in this instance, we're counting the number of items inside of this list. So this is polymorphism with user-defined functions. So you see that our function, it's actually taking many forms. You can call it with a string, you can call it with a list, you can call it even with a tuple, and it would still count the length of whatever or the number of items that will be contained inside of your particular string, list, or tuple, is it? So let's move on to the next section. We want to go ahead and look at polymorphism with operators. So here we can make use of the plus operator. I think that's the perfect example of how you can use polymorphism with operators. So let's go ahead and call print. Then we can say 5 plus 3. Let me just put a space in between so that it's more readable. Then we can also print. Let's say let's greet the world. It's always a good idea to greet the world in programming. So hello plus, then we can say world right there. Then let's also have another example. We can even concatenate lists, as it were. So we can have 1, 2, and 3 right here. Then we can say plus. Then we can say 4 and 6, right? Deliberately skipped 5 there. Alright, so let's just go ahead and copy that border that we had going on earlier in the output. So just before we call our print there, we can paste this over here. Right, so let me just clear out the console there. maybe make this bigger so that you can see the output more clearly. All right, so hit enter and you see that we have 5 plus 3 evaluates to 8, then hello plus world evaluates to hello world, and 1 2 3 plus 4 6 is going to give us one big list, is it? So again, this is polymorphism, but this time around with operators. So the plus operator, we say it's polymorphic because it can take many forms in different use cases. So in this on line 26, it's adding 2 integers. On line 27, it's concatenating a string, rather 2 strings. And then on line 28, it's actually concatenating 2 lists, as it were. So this is polymorphism with operators, right? Then the last example that we want to look at is polymorphism with class methods. So let's actually go ahead. Maybe let me just recycle that border, use it again here. So let's have a class called animal. Then inside of the class animal, we're going to define a function called speak. So remember that any method that you define inside of a class, it's always going to have the self parameter or argument, as it were. Actually, it's called a parameter. The argument is what you are going to supply when you call that particular method. So it's always going to have the self parameter there. Then inside of speak, we're just going to call the print function. Then we say animal makes a sound, right? Then from the animal class, I'm not really sure if we have covered inheritance, but anyway, we are going to define another class called dog, and dog is essentially going to extend the animal function, as it were. So the animal class, as it were. Then here we are going to define, again, just as before, we're just going to define a function called speak, and that is before it has the parameter self. Then we are going to say print here. Then we say dog barks, right? Then we also going to have another class called cat, and as before, cat is going to extend the animal class. Then we can also define a function called speak inside of the cat class right here, and essentially it's just going to do the same thing as the other functions that we've defined earlier, but this time around we're going to say cat meows, right? I love cats, by the way. They're my favorite type of pet. Though I don't have a cat, but if I ever have a way to have a pet, I'll have a cat. Okay, so now that we have our 3 classes, maybe what we can go ahead and do is let's have an animals class. Sorry, an animals list. Sorry. So inside of the animals list, I'm going to instantiate 3 animal objects of each respective type. So we are going to have a dog object, a cat object, and an animal object. Make sure that animal is spelled correctly there. Then after that, we are going to use the for loop to iterate through the objects inside of our class, is it? So we are going to go and say for animal in, actually let me just use a so that it doesn't confuse you. So animal in animals, right? What do we want to do? We want to take the animal object and call the speak function, is it? So if we go ahead and save this, open the console, clear out the console, then run. Wait, did I put that border thing? Yes, I have it. All right, so let me just make this a bit bigger so that you can see. Clear the screen, then run the script there. So you see that it says here that dog barks, cat meows, animal makes a sound, is it? So what's happening here is that all the classes, they have a method called speak, is it? We defined all the classes with a method called speak, but you see that each class implements it differently. So the animal class, which is the super class, right? It says animal makes a sound. Then inside of the dog class, we did extend or we did inherit the animal class, but the dog class is actually implementing its own version of speak, so that whenever you invoke or whenever you create a dog object and you call the speak method for the particular dog object, it's actually going to call its own method, this one, even though it inherits from the animal class. And it's the same thing going on for the cat class right here, right? Though the cat class inherits from the animal object, from the animal class, it actually implements its own version of speak. So when we call speak for the three animal objects, we see that each animal object is going to have its own implementation of the speak method. So this is polymorphism in class methods, is it? And I think that's just about it for polymorphism for this particular course, because we would actually even go a bit further to look at polymorphism using a common interface, but I think that's beyond the scope of this course, is it? So other than that, I think that's just about it for this course. I will see you guys in the next one.